In this video, we're going to be testing graphs for symmetry. So you can see on the screen here, we have three different types of symmetry. We have a graph that's symmetric to the y-axis. So that means that the y-axis is the line of symmetry. So you can see we can fold this graph on the y-axis and one part of the graph falls on the other. Our second type is symmetric to the x-axis, and I'm jumping all the way to the right. You can see all the way to the right that the x-axis is now our line of symmetry. If we fold this graph on the x-axis, one part of the graph lands on the other. And then our third one, which is in the middle, is a graph that's symmetric to the origin. So a graph that is symmetric to the origin can be rotated 180 degrees and it will look exactly the same. So another way of thinking about this is if we take that graph and we reflect it over the x-axis. So over the x-axis it would land here. And then we reflect it over the y-axis, then it will land on itself. So it either has 180 degree rotational symmetry, or if we reflect it over both the x and the y-axis, it will land on itself. And that's what's called origin symmetry. So now for the three parts below, I'm just going to draw a graph that has y-axis symmetry, x-axis symmetry, and then origin symmetry. So let's say we have a graph that looks like this. And the directions say, finish this graph so that it has y-axis symmetry. Well, all we have to do is reflect this over the y-axis, and we get a shape that now looks like a parabola. Say the directions give you the same graph, but now they say, reflect this graph or complete this graph so that it has x-axis symmetry. So now I'm going to just reflect this over the x-axis. And now we have two pieces that are going in opposite directions. Just want to make a little note of this. When a graph has x-axis symmetry, you're going to see that it is not a function. Right? A function has to pass what's called the vertical line test, meaning if you draw a vertical line anywhere, it can only pass through the graph once. Here you can see that it passes through the graph twice. So if we have an x coordinate here, an x input, it produces two different y outputs. So any relationship, any graph that has x-axis symmetry is not considered a function. Okay, well, let me jump to the third part here and look at something that has origin symmetry. So let's start with the same graph. And now we're going to complete this so that it has origin symmetry. And I like to draw this first reflecting it over the x-axis and then reflecting it over the y-axis. I have a little bit of trouble just trying to draw this with 180 degree rotational symmetry. So I'm going to reflect it over the x-axis. I'm going to draw it as a dotted line because it's not part of my final answer. So that's over the x-axis, and now I'm going to reflect it over the y-axis, and it looks like that. So now we have two different parts of the graph, one in quadrant 1, one in quadrant 3, and they're going in opposite directions.